Okay, I've got another rational function to graph. This one's a little complicated. There's some stuff going on here. So break it into pieces, and I'm going to start with this top factor right here. Notice that is the only factor on top. That means we're only dealing with one x-intercept, and it's going to be located at 2, 0. It's as if you set x minus 2 equal to 0 and solved it. Okay, so that's it for x-intercepts. I'll talk about this exponent in a bit. That matters. But for locating the x-intercept, it doesn't. Now the y-intercept, these ones are easy, right? We just set x equal to 0, and that tells you where the y-intercept is located. And what's so nice about this unfactored form right here is watch what happens as all the x's become 0. Just about everything wipes out, and all you've got left is negative 12 over negative 4. Well, that's the location on the y-axis. You could say 0, negative 12 over negative 4. Now that looks a little weird, right? We can do better than that. Negative 12 over negative 4 is just 3. So this y-intercept is going to be located at 0, 3. And I can clean this up a little bit. Okay, 0, 3 like that. Coming around to vertical asymptotes. These are factors which are on the bottom. And just about every rational function has them. It doesn't have to, but they usually do. They also can't be repeated on the top. So notice there's no x minus 1, there's no x plus 4 on the top of the fraction. That would mean they're wholes. In this case, though, they are vertical asymptotes located at x equals 1 and x equals negative 4. And the last feature I'm going to come around to is the end behavior, or the end behavior asymptote. Look at the balance of this function. I've got an x squared on top, x squared on bottom. That means equal weight. Okay. Now you might look at this and say, well, that's not equal weight. You forgot the 3, right? What about the fact that this is actually a 3x squared? Well, it doesn't matter about the 3. All I care about is the exponents, not the coefficients. The coefficients matter for locating the asymptote, but for determining what type of asymptote it is, all that matters is they are equal exponents. Now what that means is you have a horizontal asymptote, but it's not located at y equals 0. It's located at the ratio of the coefficients. So we've got y equals negative 3, and the coefficient on the bottom is really just a little 1 right there. We don't write it, but this is negative 3 over 1. Or, you could just say it more simply, y equals negative 3. Okay? So let's start graphing this thing. I'm going to put all asymptotes in red, because I like having my asymptotes in red. They look dangerous. Don't touch them. Negative 3 for the horizontal asymptote. Vertical asymptotes, what were these? 1 and negative 4. Something like that. So there's my asymptotes. I'm going to draw the intercepts in black. I've got an x-intercept at 2, 0, a y-intercept at 0, 3. I don't know, somewhere around here. And now we'll draw the function. Well, I mentioned that the asymptotes are really something not to be trifled with, right? You don't just go out and touch them. You couldn't, for example, connect the function like that. That's not allowed. It's a vertical asymptote. You never, ever want to touch those things. So you have to go around it, either by sliding up like this or sliding down. Now here's a problem with sliding down. Look what I just did. I created an x-intercept where there wasn't supposed to be one. Right in there, I crossed the x-axis. So that's not allowed, meaning you can't go down in this case because of the location of the asymptote and the lack of x-intercepts. You have to go up. And that's the same as true on the other side. You're going to have to go up in this case. We can't cross that x-axis. So let's look at the other side. All the way on the left, I think, over here. Notice there's no x-intercepts. Okay? So because you have no x-intercepts right there, that means your function cannot cross it. So I'm going to have to come in from this side and go like that. Okay? So there's my function right there. Let me clean this part up. And now I'm coming around to the right side of the graph. Well, I know I have to cross the x-axis right here. So the question is, do I come in from the top like that? Or do I come in from the bottom like this? Or something else? Well, we have two clues. Actually, one really good clue, really. If you look at the vertical asymptote, let me clean this up a little bit. What is the vertical asymptote in the equation that produces this asymptote right here? It's this x minus 1. That's what I'm looking at right here. This is x minus 1, that factor. And remember, this is an odd asymptote because the factor has an exponent of 1, right? That's just a little 1 outside the factor. It's like there's no exponent there at all. So because it is odd, that means you have to come in from the bottom side. Okay, it has to be opposite to the left. So the left and the right have to be flipped. So we're coming in from the bottom, but I still have to hit that x-intercept right there. So I got to come in kind of steep like this and come up to touch that x-intercept. You'll notice we're crossing a horizontal asymptote. That is okay. I made these things sound scarier than they need to be. Horizontal asymptotes are not electric fences. They're really more like, I don't know, a shrub. And if you need to, you can jump through it in an emergency, right? Don't do that at the ends. End behavior asymptotes are really asymptotes at the ends, but in the middle, they're more squishy. You can cross over them if you need to. And then the question is, what's going on at that x-intercept right here? This guy. Well, if you notice that, see, that's even. So in this case, I've got to bounce. So let's bounce off that thing and then approach the asymptote like that. And there we go. That's our completed graph.